In this nugget, we're going to cover some of the functional concepts and architecture for SQL Server 2008. We'll start with a brief overview of the terminology, just to make sure we're all on the same page when we're using specific words like record set or record or field or domain or whatever else. Then we'll briefly look at the purpose of SQL Server, which is really the purpose of any kind of relational database management system, or RDBMS. We'll briefly look at the Transact SQL or T-SQL language that SQL Server uses as, well, not only as its scripting language, but really as the command language that makes it do anything. Then we'll look at the difference between data definition language and data manipulation language statements. And finally, we'll wrap up with a look at how databases really look under the hood. That's going to give us a lot of information for making planning and installation decisions for SQL Server. Once we know how something works, we can make decisions to sort of make it work better. So let's get started. So let's start with some terminology. First of all, a database is sort of a collection of data, usually stored in a file of some kind. And the deal with a relational database management system like SQL Server is that a single server can actually support multiple databases. So this is the usual icon for a database. A single server can actually attach to all of these and serve it up to people. Each database is pretty much self-contained, meaning it's got everything inside of it that database needs to function with whatever application is using it. But the server does have some broader server level configuration things, like its server name and broad server-wide administrators and so forth. Now, within a single database, you've got one or more tables. Now, a table really is just a grid. In fact, it's not entirely unlike an Excel spreadsheet. It's got columns and rows. And in fact, most database people will refer to these as columns and rows. There are some other terms, though. Sometimes a column can be referred to as a domain. That's kind of an old school name. The old school name for a row is an entity. And sometimes you'll also hear a row referred to as a record. And so a set of more than one row or more than one record would be referred to as a record set. Now, SQL Server is referred to as a relational database management system, or RDBMS. And there's a reason for that. Within a given database, again, you've got multiple tables. Let's say we've got table A, which contains, let's say it's customers. That might be their names, their addresses, their phone numbers, and so forth. And we've also got table B, which contains orders. Now, orders are placed by customers, so these two tables are related to one another. For example, one of the columns within the orders table might be the customer ID. And that way we can track which customer placed the order. Now, yet another table, C, might contain the items that a customer has ordered. So that is related to the orders table. And just as the orders table might contain the customer's ID, the items table might contain the order ID that the item went with. And so when you were looking up all the items that a particular customer ordered, you'd have to relate these three tables to one another. Now, this is something that even Microsoft Access can do, but you don't typically refer to Access as a relational database management system because it's not server-based. It's really just a single application opening up one or more files. With SQL Server, it's designed to open the files on the server and allow clients to connect to it over the network, and it's designed to manage multiple databases simultaneously. Now, typically, these relationships don't cross databases. Typically, every single table that has to do with a particular use or application, customers, orders, and items, all live within the same database. However, that's just really for ease of programming and for performance reasons. It's not impossible for data to be related to a completely different database or even on a completely different server. For example, we might have a database sitting over on server A, which contains all of our current customer order information. Over on server B, though, we've got another database which might contain older archived information. Now, typically, your application is going to rely on the data that's contained in A. We'll call that the live data. However, occasionally you may need to go into the archive to look up information. So you might grab some customer information out of A and relate it to old orders in B. And again, that might be a different database on the same server, or it might be a database on a completely different server. So that's one of the strengths of a relational database management system, is its ability to quickly connect this data to other data so that you can really have a broader application. So when we talk about the purpose of SQL Server, what we're really saying is we've got this set of multiple databases, and they're going to live on a particular server. And what SQL Server as a product does is provide some shared resources for that. It provides the shared network connectivity so that clients can connect and retrieve data or add data or change data. It provides storage so that the databases have some place to live. It provides performance optimization things, things that we'll talk about in a little bit, like indexing. SQL Server is actually also a programming platform. So within a database, we can have code that runs inside the database, triggers that run automatically in response to certain actions that occur within the database. We can have pre-stored reports, database diagrams, all sorts of other information and execution that can live inside the database. SQL Server also provides some shared management capabilities, and that typically lives at a server-wide level. And that might be things like backing up databases or restoring databases or scheduling specific tasks, maybe an archive or a cleanup task that's going to occur every night or every week or whatever else. So the idea of just having databases is really the core of what SQL Server is all about. But SQL Server differentiates itself from something like Microsoft Access by providing this shared network connectivity, storage management for the disk resources, management things like scheduled tasks, performance alerts, logging, all kinds of different management things you can do with SQL Server. And it provides the ability to execute things like code and trigger and run reports, all from within the database itself. So those are ways for developers to put code in a different place for performance reasons, or to maintain data continuity and consistency, or to implement business rules and so forth. So SQL Server is really a broad platform for doing a lot of different things with all of your data. Now let's talk language. Relational database management systems, almost since the beginning of time, have used a language called Structured Query Language, or SQL. Well, most vendors back in the day started to adopt sort of proprietary versions of that, although they had a lot of overlap on certain types of language elements. Specifically, the language elements intended for data manipulation, or DML, data manipulation language, tended to be pretty much the same across different vendors, with just really minor variations. So to help make that a little bit cleaner across the industry, the American National Standards Institute created a standard called ANSI SQL, and there have been 2 or 3 revisions of that over the year. Well, for the majority of its data manipulation language, SQL Server 2008 fully complies with the ANSI SQL standard. Now, data manipulation basically means adding data to a database, removing data from a database, and changing data that's already in the database. That doesn't give you any management capability, though. It doesn't let you create new databases. It doesn't let you check performance or optimize things or anything else. So the data definition language is the second subset of SQL. Now, because every relational database management system works a little differently, whether it's Oracle or IBM or MySQL or SQL Server, the data definition language really can't be standardized. So each vendor comes up with their own variant of the SQL language. Microsoft's is called Transact SQL. And a lot of times you'll just see that abbreviated as T-SQL. So Microsoft's sort of superset of the SQL language is called T-SQL. And part of that does comply with the ANSI SQL standard for data manipulation language. Now let's take a look at what some of these things actually look like. Now, a full rundown of the entire SQL language is definitely beyond the scope of what we're going to do here, but I just want to give you sort of a flavor for what it looks like and how it behaves. For example, to get data out of a database, you might type a query like select ID, name, address, whatever other data you're trying to get out from, and then the name of the table, let's say it's customers, and you might narrow that down to say where the customer's state is in Nevada. And so that's a simple DML, or data manipulation language query, and that does comply with the ANSI SQL syntax. To delete data, you might say delete from customers where ID equals 5, and that'll delete the customer whose ID column is equal to 5. So that's just sort of a look at what T-SQL queries look like. Now for data definition language, you might say things like create table orders, and then you would follow that with some more information about what columns you wanted it to have and what data type each column would contain and so forth. And that's specifically for the T-SQL side of the syntax. Now the fact is that for simple things like creating a table, every single vendor's version of SQL tends to look maybe not exactly the same but really similar. And that's a benefit. So if you find yourself having to work with other relational database management systems, knowing T-SQL will sort of give you a head start on what those individual vendors are all doing. Now we need to talk about how databases work. Now let's start with how databases are stored. We're going to ignore the logical business of tables and rows and columns and talk about how the data physically lives on disk. On the disk you've got one or more database files. That's how the NTFS file system sees it, not unlike an Access database, only they usually have an MDB or MDF or some other file name extension. But within each database file, the data is physically organized into pages. And that's what they're called, pages. Each page is exactly 8 kilobytes in size. Now, that actually has some important bearing on planning decisions. So within this file, in the case of SQL Server, this file will either have an MDF or NDF file name extension, and we'll talk about the differences between those a little bit later. So within that file, we've got all these pages, and that's where the data physically lives. Now, a single row within a table has to fit within that 8K page, with only a couple of exceptions. So that means as you're planning things, you might say, well, okay, my customer row is going to have an ID column, and that ID is going to be a number. Well, that number is going to take up a certain amount of storage, and so that within your page eats up a little bit of what's available. Now we're going to have a customer name. Well, do we need 100 characters for the customer name, or do we need 300 characters for the customer name? It's an important decision because every character takes up a little bit more space in the page. Then of course you're going to have things like the address and the city and then the state and then a postal code and all sorts of other information. It's all eating up space in the page. Well, if a single row is less than about 4 kilobytes, then you'll be able to fit 2 of those within a single 8 kilobyte page. If, however, you've gone a little bit overboard and a single row actually takes up just over 4 kilobytes, let's call it 4.5, well, then the rest of that page is going to be wasted because there's not enough room to fit another row in there. So all the row has to live within the page, and I said there was a couple of exceptions, and there are. Because you might need to store large types of information in there, maybe the digital data for a photograph, or a really long set of notes for customer service notes or something like that, you can have special types of fields that don't live entirely in the page. Instead, they store their data on a separate page, or even a set of separate pages, and what lives in the main page is just a pointer to that. These are typically referred to as binary large objects, or blobs. And within SQL Server there are really 2 types. There's the type of blob that holds text, and the type of blob that holds binary data. That might be things like a file, or like a PDF file, or maybe a JPEG for a photo of something. So those are your blobs, and that's how SQL Server stores them, and that's really how it gets past the 8 kilobyte limit for certain types of large data. Now in SQL Server 2008, a brand new type of thing was invented, and this is also a pointer that lives on the page, but instead of pointing to other pages, it actually points to files on the file system. So we'll draw a little open folder there, and that'll represent the file system. This is called a file stream. And Microsoft created it because blobs aren't necessarily the most efficient way to store tons and tons of data. A file stream can be up to 2 gigabytes in size, and that's a lot. So it can either put a link inside the page, or it can all be linked out to this file. Now, typically, a blob is considered useful for 250 kilobytes or less. Anything over 250 kilobytes, and you should not be using a blob, you should be using a file stream. The difference is that the file stream does not live in this MDF or NDF file. It actually lives as a bunch of separate files in the file system. So a downside is that you can't just back up the MDF. If you're going to grab a file level backup, you also need to grab all of these file streams. Blobs live inside the database file. They live in these 8K pages. They just happen to live in separate pages that are linked from the main data page. All right, all this business of pages becomes important in looking at how SQL actually modifies data. So let's say again that we've got the database file, and in it are multiple pages full of data. And each one of these is 8 kilobytes and stores one or more database rows. So when an instruction or query comes into SQL Server to modify something, let's say a query like update, which is going to change some data, SQL Server gets that query from the client, looks at it, and says, okay, in order to execute this query, I'm going to need to change this page, and this page. Those are the pages that are affected by the query. So over here is going to be SQL Server's memory. We'll label this memory. And this is actually the volatile RAM of the server. And over here is the disk storage. So the first thing SQL is going to do is load the affected pages into memory. Then it modifies those pages, but it does not actually write them right back out to disk. See, it knows that there might be another query coming down the line that's going to require these same pages. So why write those out to disk if we're just going to be modifying them again in a minute? That's not very efficient. So it leaves them in memory. What it does do, however, is in a separate file that does live on the disk called the transaction log, it makes a little list of the changes it's made. And that does get written right to disk. And this isn't exactly a text file, but you know what? You can think of it as that. It's a very simple operation for it to just append another change that it's made back to this transaction log. Now, eventually in SQL Server terms might be 5 seconds later, but that's an eternity for the computer. So eventually, SQL Server is going to realize that it needs to write these pages back out to disk. Maybe it's run out of memory to work with, because it only allocates a certain amount of memory to cache these pages in memory. So maybe that's getting full and it needs the space back. So it's going to write these back to disk, back into the database file. And now that they're safely on disk, where they can't be lost in the event of a power outage, it goes back to the transaction log and kind of checks them off, just so it knows that those have been done. So let's look at how that plays into a recovery scenario when you do have a problem like losing power or a server crash or something like that. Let's propose a situation where we've got a transaction log, and we're just going to call this the T log. By the way, this lives in a database file with an LDF file name extension. So that's how you can really look at it on the disk and determine what it is. So we've made 1, 2, 3, 4, 5, 6, 7, 8 changes. Now those all represent changes that SQL Server has made. And let's say that 1, 2, 3, and 4 have had their pages written back to disk. And then all of a sudden we lose power to the server. And for some reason we don't have a power backup, or SQL Server crashes, or a meteor hits the server, or something bad happens. Now keep in mind, changes 5, 6, 7, and 8 have never been written out to disk. The result of those changes was only stored in SQL Server's memory, which is now gone. Now, does that mean we've lost those changes? No. What happens is SQL Server starts back up and immediately looks at the transaction log and sees that there are uncommitted transactions. So in its memory, it goes out to the database's MDF file, looks for the pages that were modified by those entries, loads those pages back into memory, re-executes these changes, writes those pages back out to disk immediately, it's not taking any chances this time, and marks those transactions as completed. So the transaction log is really kind of a to-do list. It says these transactions need to be done and written back out to disk. Once SQL Server does them and writes them out to disk, it checks them off of the to-do list. If something happens to prevent SQL from getting one of these changes written back out to disk, when SQL Server restarts, it still has this to-do list that it can work with. Now, one of the problems you might be thinking about is this transaction log has the opportunity to get really, really big. So when you make a full database backup, SQL Server actually goes along and says, okay, I did this one, that got written to disk, I don't need that anymore. I did that one, I did that one, I did that one, did that one, did that one, did that one, and did that one. And it clears out the transaction log. That way SQL Server knows that not only were those changes done and committed to disk, but now they've also been backed up, so they're safe. So let's say you ran your backup on Monday morning, and over the course of Monday afternoon, you build up more changes. 1, 2, 3, 4, 5, 6. And these all get written to disk. Well, most of them get written to disk. And then you have a server failure. Your actual database file gets corrupted. But your transaction log is fine. So what do? Well, you go to your backup disk and you restore the database file from Monday morning. Now that would normally mean that you've lost some data. You've lost whatever happened between Monday morning and now. We're going to bring that database back to Monday morning and then go back to the transaction log and look and see what's in there. And we're going to have 1, 2, 3, 4, 5, 6. And even though these ones were checked off earlier, they're not in this copy of the database, which was made earlier. So SQL Server is actually going to undo those check marks, replay all of these transactions from the Monday morning backup database, and then write them back to disk in that database. So basically, it's kind of an incremental backup. We started with this database file, replayed all the transactions that have occurred since then, and now that database file is completely up to date. The only time in SQL Server that you really lose data is if you lose a database file and you lose the log file. If you lose the database file and the transaction log, then you're going to lose whatever data was in the transaction log. You're going to have to roll back to your most recent database backup. And that's one reason, and when we start talking about storage planning, we'll get into this. That's one reason that we tend to keep the LDF file on a separate disk, so that if we have a disk failure with the database file, we don't lose the log file at the same time. And you can actually perform a transaction log backup on a regular basis. Some companies do it as often as every 10 minutes or every hour, so that they always have a copy of the transaction log. If they need to do a full recovery, they go back to their most recent full backup, restore all of their transaction logs, and then start replaying the transaction logs out of those. Now, in a recovery process, that's going to take some time to replay all those, but sitting and waiting for that to happen is definitely better than losing all that data completely. Now, another thing SQL Server has to be good at is finding data quickly. If we have this database file, this is our MDF file, and we've got all these different pages of data that live in there. If we've got millions and millions and millions of rows of data, how can we find things quickly? Well, SQL Server accomplishes this through indexes. Now, typically you create an index on one or more columns, like you might have a customer name index. The index actually lives within the same MDF file, and really all it is a different representation of the data. It'll say that customer name Jones is located on this page, and customer name Smith is located on that page, and customer name Xavier is located on this page. The index is in order based on whatever column it is. So it's very quick to look something up. If you know you need to look up Smith, you don't have to scan through the entire index. You know you can probably jump to the halfway point and see if you're in the S's yet. If you're not, maybe jump ahead another 20% and see if you're in the S's. It's really just like scanning through a phone book. You can flip through it, quickly find the name that you're after, and then that'll tell you which database page has what you need. Now, SQL Server supports two types of indexes. The first is called a clustered index. With a clustered index, the actual data pages are stored in order. So if we did a clustered index on customer name, then the physical database pages would be in order by customer name. You can really only have one clustered index and get a lot of use out of it. The other type of index is a non-clustered index. And that is a separate set of pages that just lists the data that you're after, like customer name, and points to the data page. That allows you to have a different sort order. For example, we might have a clustered index on order ID, so that the data pages are going to be in order by order ID. And then we might have a non-clustered index on customer name, and that will point to the separate data pages so that we can look them up. Now there's another technique called a covering index. Let's say we want to go to our database and we only want to get a list of all the customer names. Now our actual data pages will say are in order by order ID. That's the clustered index. But we've created a non-clustered index, and we've done that on the customer name. So this non-clustered index is going to look something like Jones, Smith, and Xavier. The clustered index is going to look something like order 123, order 456, and order 789. If all we need is the customer name, we can go to the index and get the customer name from the index. We don't actually have to go to the data page itself. That's called a covering index. And the reason that's important is because you can actually create non-clustered indexes that have more than one column in them. We might have a non-clustered index that has the customer name and their address and maybe their city for some reason. If we needed to search on those things frequently, that would be a good reason. And if the only things we tended to need were the customer name, the address, and the city, then we would be able to look that up right in the index, and we wouldn't have to go to the actual data pages. So it saves SQL Server a step when it's doing that setup. So that's kind of a performance tip. And again, when we talk about performance optimization in a later nugget, we're going to come back to this concept and explore it in a little more detail. Now, the last thing we're going to explore is something called a trigger. Now, we've already said there's a lot of things you can do to a database. You can select data or get it from the database. You can update data that's in the database. You can delete data that's in the database, and you can insert new data into the database. These are the four basic data manipulation commands in the T-SQL language. We also said that there are data definition language commands, things like create to create tables or indexes or whatever else, drop to remove tables, indexes, or whatever else, and alter to change ones that are already there. Whenever one of these things happens inside the database, SQL has the ability to run something called a trigger. And you can have DML triggers that run in response to DML commands and DDL triggers that run in response to data definition commands. What goes inside that trigger is your code, your script. For example, You might say that I want a trigger to run whenever someone deletes something from the database. And it's going to be from a particular table. So let's say when someone deletes a customer record, I want a trigger to run. I want that trigger to delete all of that customer's orders, and I want it to delete all of the items that they've ordered. That way I don't have orders and items sitting around in my database that aren't attached to a real customer. If you delete the customer, then I want you to run a trigger that also deletes their orders and deletes their items. Now, a more useful use for that might be to say, when someone tries to delete something from the customers table, instead of allowing them to do that, I want to move that data off to an archive. So that way I'm never really losing any data, and that's another use of a trigger. So before I allow the delete to occur, I'm going to grab up all that data, insert it into an archive database, and then I'll have it. Then I'll allow the delete to proceed. So triggers are a way of enforcing data consistency. They're a way of enforcing data integrity. They're also a way of enforcing security. For example, we might say, when someone tries to alter a database table, I want to run a trigger that sends me an email letting me know it happened and writes out some sort of log entry so that I know who tried to alter it and when. So that's a way of enforcing security in your database, is to have this DDL trigger watching for alterations and then automatically taking some type of alert or notification action when that happens. So the triggers are something else that we'll explore in a later nugget, but just for right now, know that they're a critical part of the way SQL Server operates. In this nugget, we've covered SQL Server's terminology, and we've looked at the purpose of SQL Server, or really the purpose of any relational database management system. We looked at the Transact SQL language that SQL uses as its control and scripting language, and covered the differences between the DDL, or data definition language, and DML, or data manipulation language, sides of T-SQL. Finally, we looked at how databases work. We talked about how storage works, how file streams work within SQL Server 2008. We looked at transaction logs and so forth, database indexes, and even database triggers. I hope you found this to be useful, and I'd like to thank you for viewing.